So in this video, we're going to start introducing the idea of hypothesis testing. So I just want to remind you of the central limit theorem that we talked about. So if a population standard deviation sigma is known, then the sample mean follows a normal distribution with the mean mu and the standard deviation sigma over the square root of n. So we might have drawn it like this, where we said, okay, it's going to be normally distributed, and the mean is mu, and the standard deviation was sigma over the square root of n. That was the distribution of x bar. So most of the means are going to kind of fall here really close to mu, but every once in a while we're going to get one that falls out here, or maybe more in here, and then sometimes some lower, right? But then it sort of creates this distribution where most of them fall around mu, but they are spread out with a standard deviation of sigma over the square root of n. So this is one way that we can write it in that notation, okay? So when I read this, I say x bar follows the distribution, a normal distribution, okay? And then this specifies that the mean is mu, and the standard deviation is sigma over the square root of n. So that's just one way to write. Maybe I should write this in words. This thing here just means that x bar follows a normal distribution. With mean equal to mu and standard deviation is equal to sigma over the square root of n. That's all that that's saying. Now the second expression here, remember we talked about the z-score, right? And so the z-score was always x bar minus the mean mu divided by the standard deviation, and then this became our z-score, meaning it followed the standard normal distribution, which is the normal distribution with mean mu, with mean 0 and standard deviation 1, okay? So just once we kind of remember that, those two statements are kind of equivalent, we're going to need this as we sort of get into hypothesis testing.